Okay. uh, so basic physics behind of the laser. Okay, so we are going to understand the principle of laser with the help of three processes. One is the absorption, another is the spontaneous emission, and third one is the stimulated emission. Okay, stimulated emission, our interest is to understand stimulated emission very well. Okay, so three type of transition is here. Quantum processes, that is, before that we have to know three type of transition, that is quantum processes that takes place between the energy photons and matter atoms. Okay, so these are the quantum processes, because generally we say that the laser light is a quantum light because there is a no classical explanation of laser light. But yes, with the help of quantum mechanics we can explain the laser phenomenon. Okay, first process is stimulated absorption. Absorption, just see here. Suppose your atoms is in the ground state at the initial stage. So E1 is your ground state and E2 is your excited state. Okay, E1 is your ground state and E2 is your excited state. Suppose the incident photon is here, the photon is shown in here, having the energy h into nu or h into f, h into nu or h into f. Okay, where h is the Planck's constant, f is the frequency. Okay, so due to the incidence of this photon, electrons or atoms gains the energy. Okay, among of these four electrons, as you can see here, one goes to the excited state due to the absorption of photon, and here you can see this is the one electron is in excited state. Due to why? Due to this incidence of photon. Okay, so this process is called the absorption, because photon absorption process is taken place over here. Okay, so you can see that when an atom is ground state, it will jump to the excited state by absorbing photon energy. Okay, and so the energy of the absorbed photon is how much? It is equal to the energy difference between these two energy state. Okay, so delta E is equal to E2 minus E1. This is the energy difference between these two state, and which is equal to the h into f. Okay, where f is the frequency. Okay, so and this process is explained with the here with the equation, like A is our electron. Okay, A is electron or atom. Just see here, once it is if a atom absorbs the photon h nu, so A star is our final product and A star is the atom in E2 state. A star is the atom in E2 state. Okay, so this was all about the absorption process. So what is the spontaneous emission? Just like see here. Okay, when it goes to the excited state. Okay, when it goes to the excited state, we have seen in the absorption process that when atom gains energy due to some incident photon, it goes to the excited state and it raised up to there 10 to the power minus 8 second, raised to the up to there 10 to the power minus 8 second. Okay, so electron is in excited state right now, and how much time it stays to the E2 state? It stays up to the 10 to the power minus 8 second. This is the lifetime of state. We generally say it is the lifetime of that particular atom. Okay, so after the 10 to the power minus 8 second, atom de-excites by its own. That line is really an important. Okay, atom de-excites by its own without taking in any external energy. Okay, so this is the atom which is already in excited state. Now here you can see that while coming to from ground state to the excited state to the ground state, it emits against the energy in the form of photon, and the value of that photon is again h into f, where h is the Planck's constant, f is your frequency. Okay, so this is the before scenario, this is the after scenario. In the absorption process, that you can see the absorption is taken place here, and in here in the spontaneous emission, the emission is taken place over here, but it is happening, or it is happen spontaneously. No external energy or no external triggering is used here. Okay, and therefore this process is called as the spontaneous emission, because it is happening spontaneously. Okay, so here is given the explanation. When atom is in excited energy state, it decay to a lower level, emitting a photon of radiation. Okay, and emitting photon is in random in direction and in phase. Okay, so this photon is in random in direction and in phase. Therefore the only spontaneous emission process cannot produce laser, because the emitting photon is in random in direction and not in phase. Okay, or random in phase. Okay, so again the value of this photon is given h nu with the help of this equation, And again the equation is gives us to idea about the spontaneous emission. Initially our atom is in the E2 state, but while coming to the ground state, that is H, it again emit energy in the form of photon. Okay, so this is all about the spontaneous emission. Okay, now what is the stimulated emission? Now just see here, it is really an interesting process. Now your atom is already in excited state. Your atom is already in excited state. Now, some external photon is incident with your system, or some external photon is encounter with the system. Which system? The system which is already in excited state. Okay. So, this incident photon triggers our electron which is already in excited state, and it makes downward transition. It makes downward transition, and while coming towards the downward transition, it also emits the energy in the form of photon, the electron, and this is incident photon. This is incident photon. So we are getting two photons. Okay, or just simply we say that one photon produces two photon. Photon produces two photon. Okay, I'm again explaining the stimulated emission process here. Our system was, or our system is already in excited state, and some incident or some external photon is encountered with our system. It triggers our electron which is already in excited state, and it makes the downward transition. While coming toward the ground state, it also emits the energy in the form of photon, and incident photon is already there. Okay, so ultimately from the one photon we are getting two photon. Okay, so explanation is again given here. When atom is already in excited energy state, by passing a photon, energy will cause the atom decay to a lower level, emitting a photon of radiation. Ultimately one photon produces two photon. Emitted amplified photon is at the same wavelength. Okay, this is really an interesting topic, huh? This is really an interesting topic. Just see here, ultimately we are getting two photons, but this is suppose the photon which is emitted by the electron, and this photon is suppose incident photon. Okay, so emitted photon or amplified photon is at the same wavelength. Both have a same wavelength, same direction, and in same phase. This process called as a laser. Okay, so why the stimulated emission is responsible for lasing action? The answer is given because the ultimately the photon which we are getting, which gives us very high intensity, because the constructive interference happening between these two photon. These two photon again interact with the two atom, another two atom, and ultimately you are getting four photon. This four photon again interact with the four atom, and ultimately they are getting eight electrons. So this process is continuously happening over there. Chain reaction will start, and ultimately avalanche effect is created. Avalanche effect is created. Therefore, the high amount of light beam is created in the laser cavity, or in the resonant cavity, we simply say that. But this stimulated emission process is really an important, and this process mainly responsible for to producing the laser. Okay, in order to get the laser, this stimulated emission process should be the dominating process, unless or until we are not able to produce the laser. Okay, so we require this stimulated emission process very well. I hope that you are cleared about the three processes. Okay, next things we'll see understand in next lecture.